I mean, it's kind of an obvious title, but it kind of sounds like some 50s sci-fi movie or something. Vectors in space. Or did you guys ever watch the Muppets? They had pigs in space. You remember that? It was on the old Muppets that had like the actual puppets. Anyways, that's what it brought back to my mind. We're talking about vectors in space. And we need to start, first of all, looking at three-dimensional space and how we draw that on two-dimensional paper. Okay? So first of all, just looking at how this is constructed, we're really intersecting, instead of two lines like we do for the XY plane, we're actually intersecting three planes. Alright, we have three axes, the x-axis, the y-axis, and the z-axis. Okay? And the three planes that are formed, if we look at the origin as point O. We have here y, o, z, alright, that whole plane. And then we have x, o, z, that's the plane that's going to contain the x and y axes. That's the one that we've dealt with for years, okay, x, o, z. But then we have this x, o, y. XOZ has the x and the z axes. So, that image may be hard to kind of wrap our minds around, but we're intersecting three planes and finding points on those. Okay. Now here you see an example of a point being graphed in space. Right? And to help ourselves out, we do actually draw these little lines to go along with it. Okay? But let's point out a few things about this before we actually try graphing some points. Right? First of all, you'll notice the x-axis is kind of coming towards you. All right, that's kind of the front to back view. And notice this one side is dotted. Now your book does that, and I believe all IB will do that. But that's to indicate that that's the negative side, or more just to remind you that that's the negative side. Okay? And then here you have the positive y-axis, and then it's dotted to the left, that's the negative y-axis. Okay? And then z is positive going up and negative going down. That was a little more obvious. Okay? You're not always going to see the dotted, but one reason why they do that is because sometimes we'll take these things and then we'll actually rotate them around and look at them from different angles, and it's helpful if we can see what's dotted and what's solid. It helps us keep in perspective where exactly we are. Okay? Now, since we have a third axis, we also have a third coordinate. We have the z-coordinate. And we can sketch these points, we can plot these points, but we have to kind of be a little careful as we do it, okay? I'm going to show you how we would plot the point here, 2, 3, negative 4, all right? When I'm plotting 2, 3, negative 4, first of all, I'm going to start with my x, and I put the marks on the x-axis. You'll notice I try to make them parallel to the y-axis. That'll help me figure out where exactly to go for as I move over on my y-axis, okay? The y-coordinate is 3, so I'm going to put the marks on my y-axis, and you'll notice I made those parallel to the x. All right. And what this does for us is it kind of creates this little box. Okay? Some people only put one side on it, that's fine. I like putting both on there. That's not where the point is, but that did identify where the point is, either directly above or directly below. Okay? because now we need to take into account the z coordinate, that -4. Okay, so the -4, we're going to mark on the z-axis 1, 2, 3, 4, but be careful, okay? Don't just do this, and hey, there's my point, okay? You've got to think, hey, we're looking at this kind of at an angle, this is in perspective, so you have to think more along the lines of distance, okay? How far down is 4 units on the z-axis? It's about that far. So from here, I'm going to go down that far. Does that make sense? And you can use the tip of your pencil, you can use a ruler if you want, you can just use your fingers if you want. Get it at least close, alright? But I don't want to see you just put the point right here because that's right next to where your -4 was. Okay?
Wait, I'm confused. When you say don't put, you like estimate about how long it is and then draw from there?
Yes. See, this is why I like to do this little box, because that shows us I'm going to be either straight up from there or straight down from there. Then you look at your axis, 1, 2, 3, 4 units, that's the length.
Okay.
And really, you can kind of think of it like this. That's how long it would be. So now, if I just moved it, that's where my point's going to end up. You know, we're taking that distance and kind of transferring it over here. Yes?
Could you look at it like where your dot ends up is slightly below 2 units down, so you could just add 2 units and that be
Yeah, you could kind of think of it relative to this. You know, this is a little below 2, so
take 4 and then add 2.
yeah,
Go down to like the 4 spot. Okay.
yeah, you could do something like that. As long as the only thing I would mark you off for, as far as that, is if you just put, hey, 1, 2, 3, 4, and there's my point, because that shows you don't have any.
Right. But if you went like 1, 2, 3, 4, 5, 6, and then a little below 6.
Yeah, I
Okay.
mean, yeah, you could kind of do something like that. So. Okay. Let's try graphing a couple of these points. Okay. We'll put out. I kind of cheated. I saved mine, so I already have it. But try to sketch for yourself the XYZ space. Okay. And you could do it on separate or all on the same one if you want, but someone give us a point with relatively small numbers. 4, 5, 6. Okay. 4, 5, and 6. Okay. So it'll give me another point.
3, 5, 1.
3, 5, 1. Okay. 3, 5, and 1. All right. We'll call that point Q. Alright, so if you do them on the same thing, that you can tell the difference. Alright, so try sketching those on your own. And if you get both of them and you'd like to come put one of them up here, you can. I'll take volunteers.
Can we make one of them negative?
You want to do like, just to get used to,
Yeah.
make this like -5?
Yeah.
Okay. We'll do 3, -5, 1.
I think it's easier if you look at just the x and y coordinates and plot that and just go either vertically or just go down directly from that.
Well, you're kind of. Here's the thing. This is your positive x. This is your positive y. Okay. So you should have gone
That way.
this way 4, and then this way 5.
But I
Okay,
can
so
orient
4, 5.
But if I just made this the positive end of the x, this the negative end of the x, and this the positive end of the y, and this
don't do that.
Okay.
I get what you're doing. You basically you took that and you kind of just rotated it this way. I guess if you label it, I don't mind. I just don't want you to get confused when we do other stuff.
Okay,
You know,
is this just the standard way we're gonna do it?
That's gonna be the standard way we do it. You might see some sources switch the X and Y axis. They'll have the Y going this way and X going this way, but this is kind of the accepted way of doing it. Well, yeah, because you're here, so you would kind of measure with your pencil or something and just go that far up. Okay. Yeah. Well, it might be a little bit higher. I would though leave the lines, you know, just like that first picture I gave you. You know, they even do this. You know, they'll show, hey, we're coming off of here this far, we're going up this far, and just make your point obvious at the end of it. That'll help you just to have perspective.
That is 6.
So,
Without the
so
up,
the
right?
first one, is that, like, that's the distance that is.
Yeah, when you go in,
Okay, so then for the Y thing, you go back this way, you
Yes.
got it?
Yeah.
So then how do you like this way, or this way?
You can go here like this,
Okay.
and then measure your 6 and go from there.
Okay, so,
Right.
and then from this point, just one. So measure.
Oh, okay.
Yeah.
Thank you.
All right, does someone want to put their points up? So you did 3, -5, and then 1 up. Yes, that's correct. Yes, that's it. That's right. No one wants to put theirs up on the board? Oh man. Maybe if you see one more, someone will be brave enough to do Q. Alright, so P, we need to go forward 4 on the x-axis, and then over 5 on the y-axis.
Wait, isn't it -5 though? Oh wait, no, I did -5 last time.
Yeah, P was,
This is not what you
okay. So there it is. Okay. Then we need to go 6 units up from there. Okay. So there's our 6 units. You can measure. And then just go from over here 6 units up. And there's your point P. Yes.
You were just given the point on the graph. How would you know it's that those coordinates and not something else? Because it's kind of just like out there.
Well, that's an excellent question. I mean, if I just drew this point, how do I know it's not, you know, just right here? Or how do I know it's not that point? Or how do I know it's not that point, you know, and z is 0? The answer is we don't know. That's why we draw these lines to kind of show where we are in space. You've got to draw those lines to indicate, you know, where you're at. Yes.
May I please fill my water bottle?
Why don't you just do that between?
Okay.
Okay. So does anyone want to do Q now?
Yeah.
All right. Come on up.
that's my point. Sorry about the one.
alright.
So the box would be like to here, right?
Yeah.
That's not the point, but that's just, and then it'll be one up on the z-axis.
Mm-hmm.
So kind of like here.
Yeah. Yeah, that's good. Okay, thanks. Alright, so we went 3 on the x, -5 on the y, and then just up 1 on the z. So we ended up right here. Okay? It's gonna right. There we go. So there's our point Q. Okay? If you want to draw the little part going up, that's fine too. Alrighty? So that's good, that's good. Now, we're getting kind of a sense of visualizing this in 3D, and that's good, okay? Now let's start, actually what I think is the easier part of this. It's kind of challenging to draw and visualize things in 3 dimensions when it's on a piece of paper. But let's take a look at the algebraic portion of this and tie this to what we were doing with 2 dimensions previous couple days, okay? First of all, we have unit vectors. You guys have seen I and J before, but now that we have 3 coordinates, we're going to have 3 components to our vectors. So I, instead of just being 1, 0, is going to be 1, 0, 0. The unit vector j is 0, 1, 0. And the unit vector k is 0, 0, 1. That's the new one, since we have that z-axis. Okay? Now, we talked about position vectors, and here I have the point I started with, the point 2, 3, -4. And we can write that as, instead of a point, as a point in relation to the origin. In other words, we would write it as a position vector. Where is our point in relation to the origin? Alright, well, it would still just look like 2, 3, -4. Okay, but now we're thinking of it in terms of a vector. And that's helpful because then we can do different vector operations with it. Now, this can also be written, remember our differences in notation, you might also see this written like this. 2, 3, -4. It's the same vector, just different notation. Then, you see here, we also have the unit vector form. Unit vector form, we could write OP as 2i plus 3j minus 4k. Alright, so all 3 of those give us the same vector, just in different forms. Does anyone have any questions about any of those? Alright, so the last thing I want to look at today is actually finding a vector between 2 points and then finding the magnitude of a 3-dimensional vector. Okay? The nice thing about most of the algebraic parts of vectors in 3 dimensions is that you just take whatever formula you were using for 2 dimensions and then throw in the z part. Okay? None of the formulas are totally different. It's just there's an additional part to incorporate the z. So you you remember when we found the vector between 2 points, we subtracted the x component of where we wanted to end up minus the x component of where we started. And then we did the same thing with the y components. The y coordinate of where we ended up minus the y coordinate of the point where we started. Well, now, since our points have z coordinates as well, we have the z component that's found in the same way. The z coordinate of the point where we're ending up minus the z coordinate of the point where we started. Okay? And I'm going to illustrate that down here. We'll find the point A. Here's 1, 5, and then -2. Okay, so 1, 5 is going to be right here, and then there's a distance of 2. I'm going to go down. Okay? So there's our point A. So, if right here is the origin, you try to visualize it, we went forward 1, 5 over, and down 2. So we're somewhere over here. Okay? Now our other point, point B, is at -3, so we're going back here, 1, 2, 3, over 2. So here's our box this time. And then we want to go up 3. So 1, 2, 3. We take that same distance up from the corner of that box. And there's point B. Okay? Now when you draw this vector, vector AB, it almost looks like it's just going straight up. Alright, but you've got to remember this is in 3 dimensions. Okay? So remember we said if this is the origin, A was over here. Okay, and kind of down. For B, we're pulled back 3, over to the right 2, and up 3. Okay, so we're finding the vector from here to up here to get AB. So it kind of looks, depending on what angle you're looking at, it looks like it might be going straight up. But keep in mind, you know, B is kind of behind A and a little over. Alright, so don't just go based on what it looks like. So there's the vector AB drawn in 3 dimensions. Now let's actually find what vector AB is. Okay? I'm going to use this vertical notation because it's kind of helpful in this case with 3 of them. I'm going to subtract the x-coordinate of B minus the x-coordinate of A. So -3 minus 1. And then the y-coordinate of B minus the y-coordinate of A. So 2 minus 5. And then the z-coordinate of B minus the z-coordinate of A. Right? What would I get if I switched all of those? If I did 1 minus a -3 and 5 minus 2 and -2 minus 3, what would that give me? It would, all the signs would be opposites, right? And what vector would that be? BA. Alright? That'd be vector BA. So.
Wouldn't it be 3 plus 2 because 2 is negative, so you subtract to -2, wouldn't that be plus?
Yeah, it'll be 3 minus a -2 is 3 plus 2. So you're right, that's plus, so 3 plus 2 is 5. 2 minus 5 is -3. -3 minus 1 is -4. So we have the vector -4, -3, 5. Okay? Alright. Now, when we were finding magnitudes in 2 dimensions, we just used the Pythagorean theorem, okay? Well, we're actually going to be using the Pythagorean theorem. To derive this, we would have to use the Pythagorean theorem like 3 times. Okay, we're not going to take the time to derive this. They have it in your book if you'd like to see. But you'll see here the formula for the magnitude of the vector. And like I said before, the formula isn't anything totally different. We just add in a z component to what we were doing before in 2 dimensions. Okay? So if we're finding the magnitude of AB, we're going to be getting the square root of what? What would we be putting in here?
-4 squared
Good.
plus -3 squared plus 5 squared.
Alright, good. So you're taking all 3 components now, squaring them, adding them together. You get 16 plus 9 plus 25, which is 50. So the square root of 50 is 5 root 2. Okay, so that would be the magnitude of the vector. Okay? Any questions? All right, good. Let me point out a couple of things on the practice here. If I'm finding the distance from the origin to a point, what am I really finding?
The magnitude of that vector.
The magnitude of the vector OP, right? The position vector. Okay. Here are some similar types of questions. For this, number 7, take a look at that. Find the shortest distance from a point to
Straight line.
another point's easy, but to A, the y-axis,
So that's. So the y would just be back. Oh, it would be that vector coming back
The
up and
diagonal.
diagonal toward that. I know it's hard. Alright.
yeah. How do we measure the shortest distance from a point to,
Draw a straight line.
you draw a straight line,
Distance
But-
one.
would I draw it, like if
okay.
I wanted to measure from this point out here to the board, would I measure to this point on the board? Or this point? Where's the closest point? There we go, perpendicular. Whatever would be perpendicular to that surface. So think in terms of that, okay? Both here with the line and here with the YOZ plane. Okay, think about that. There actually are some examples of that in the book if you get stuck and you want to look back at those. But I think you guys can figure it out logically too. But some of these just get you thinking a little bit beyond just the basic concepts, you know. Showing that something's a right triangle in 3-dimensional space. Finding the area of that triangle. You know, some other things here as well. So, should be some good practice. But try those, come with questions tomorrow, and should be good. All right.
What?